Hi, welcome back. This is Mark, and today we're going to discuss IP addressing, particularly IPv4. So the question now is, what is IP address? So this is an example of IP address, and the IP address that you can see here is 17.172.224.47, which are represented by in a octet format. So that means each of this is represented by 8 bits, okay, in binary. But the one that we are shown are usually are in a form of decimal because it's easier to remember and it's shorter. The numbers are shorter compared to if they are in the binary format. So 17 is an 8-bit number. The 172 also is an 8-bit number, and 224 as well, and 47 as well. So all in all, you have a 32-bit or 4 bytes IP address. And IP, just a reminder, stands for Internet Protocol. If this is what is required for a device, any device that is to be connected to the internet, and for it to be able to communicate with other devices in the internet, it has to have an IP address. So, which means all devices that are connected to the internet have their own IP address. An IP address is an address having the information about how to reach a specific host, especially outside the local area network. An IP address is a 32-bit unique address having an address space of 232. Now, generally, there are two notations in which IP address is written, and that is in dotted decimal notation and hexadecimal notation. Okay, so this is the dotted decimal notation, and this is the hexadecimal notation. Okay, so the 128, the value of it in binary is 1, 0, 0, 0. You have 1, the first one, and then the rest 7 digits are zeros. Then 11, this one, its equivalent is this in binary, and 3 and 31. So this is the dotted decimal notation. Now in the hexadecimal notation, this is how it is shown. So you have the 75. Since it's in hexadecimal notation, you have to have the 0 and then the X. So 75 and then 95, 1D, and then the EA. Now next is the classful addressing. Now, the 32-bit IP address is divided into 5 subclasses, and these are class A, okay, B, C, D, and E. So, if you notice, the class A, if the first byte or the first 8-bit, if the value is between 0 to including 0 to 127, automatically you will classify that as class A. And if it's 128 to 191, it's going to be class B, and class C, and class D, and class E, respectively. You can see the values. Okay, these are the first values that you can take note of for you to be able to identify which is class A, class B, C, D, and E. Now, each of these classes have a valid range of IP addresses. Classes D and E are reserved for multicast and experimental purposes, respectively. The order of bits in the first octet determine the classes of IP address. So in the IPv4 address, it is divided into two parts. Okay, so as mentioned again, the IPv4 address is divided into two parts, which are the first one is the network ID and the host ID. Now in the diagram that you can see here, in the class A, this is the first byte is the network ID, and then the following bytes, okay, byte 2, 3, and 4 is composed of the host ID. For class B, the first 2 bytes or the first 8 bits is the network ID, and the third and the fourth byte will be the host ID, and finally is the class C is the network ID. The first, second, and third byte is the network ID, and the byte 4 is the host ID. As mentioned before, the class D and E are special IP addresses and reserved for multicast and experimental purposes. The class of IP address is used to determine the bits used for network ID and the host ID, and the number of total networks and hosts possible in that particular class. Now, each ISP or Internet Service Provider or Network Administrator assigns IP address to each device that is connected to its network. And please note, the IP addresses are globally managed by the Internet Assigned Numbers Authority or IANA and the Regional Internet Registries, RIR. Another that needs to be taken note is while finding the total number of host IP addresses, that 2 IP addresses are not counted and are therefore decreased from the total count because the first IP address of any network is the network number or network address, and whereas the last IP address is reserved for broadcast IP. Okay, the first one is class A. Now, the IP address belonging to class A are assigned to the networks that contain a large number of hosts. The network ID is 8 bits long and the host ID is 24 bits long. Okay, so 8-bit and 24-bit. The higher order bit of, if you're wondering why this is 7-bit and 0, this is this plus 1 bit is actually 8-bit. So this is just telling us, since the first bit, if the first bit is 0, that means it's class A. Going back, the higher order bit of the first octet in class A is always set to 0 as mentioned. The remaining 7 bits in first octet are used to determine network ID. Okay, so this is the network ID. The 24 bits of host ID are used to determine the host in any network. The default subnet mask for class A is 25.xxx, or this could be any number, but the first octet should be 255. This is the part where it tells us that this is the network portion. Therefore, class A has a total of 102. That's 126 because 2 raised to the power of 7 minus 2. That's why you have the 126. Here, this is the network A. Here, the 2 address is subtracted because 0000 and 127XYZ are special addresses. And for the host address, that's 2 raised to the power of 24 because it's 24 bits minus 2. And all in all, you have per network, you'll have 16,777,214 hosts, okay, for each network. IP addresses belonging to Class A ranges from these values: 1.xxx to 126.xxx. Next is Class B. The IP address belonging to Class B are assigned to the networks that ranges from medium-sized to large-sized networks. The network ID is 16 bits long and the host ID is 16 bits long. The higher order bits of the first octet of IP addresses of Class B are always set to 10. The remaining 14 bits are used to determine network ID. And the 16 bits of host ID is used to determine the host in any network. So the default subnet mask for Class B is 255.255. So this means this is the network portion, and then the XX is the host portion. Class B has a total of 2 raised to the power of 14 equals to 16,384 network addresses. And then for the host address is 2 raised to the power of 16 minus 2. You have 65,534 host addresses. IP addresses belonging to Class B ranges from 128.0xx to 192.125.x.x. So this is the 14-bit network address and then the 16-bit host address. So as you can see in the binary format, if it's Class B, it should always start with 1. The first bit should be 1, and then the second bit should be 0. So from there, if it's in the binary format and then you see this combination 1 and then 0, automatically that is Class B. Next is Class C. The IP address belonging to Class C are assigned to small-sized networks. The network ID is 24 bits long and the host ID is only 8 bits long. The higher order bits of the first octet of IP addresses of Class C are always set to 110. Okay, so that's 110. On Class A, you start with the 0 is here. On Class B, the 0 is here. And in Class C, the 0 is already here. Okay, so the remaining 21 bits are used to determine the network ID. The 8 bits of host ID is used to determine the host in any network. So the default subnet mask for Class C is 255.255.255. Again, in subnet mask, if it's 255, that means that's the network part. So you have first, second, and third. That's the network part. And you have the host part, which is the X. Class C has a total of 2 raised to the power of 21, so which means you have 2,097,152 network address. And for the host address, you have for each network, you have 254 host addresses. If IP addresses belonging to Class C ranges from 192.00x to 223.255.255.x. Okay, so this is the network part, 21-bit, and then the 8-bit part is the host part. Now for Class D, IP address belonging to Class D are reserved for multi-casting. The higher order bits of the first octet of IP addresses belonging to Class D are always set to, now you see, the 0 is here already, 1110. Remaining bits are for address that interested hosts recognize. So Class D does not possess any subnet mask, and IP addresses belonging to Class D ranges from 224.0.0.0 to 239.255.255.255. Now the Class E, IP addresses belonging to Class E are reserved for experimental and research purposes only. IP addresses of Class E ranges from 240.0.0.0 to 255.255.254. This class doesn't have any subnet mask as well. Same with class D. The higher order bits of first octet of class E are always set to 11111. And then the 28-bit, which is the host bit. We also have the range of special IP addresses. The first one is with linked local addresses. It's 169.254.0.0 to 169.254.0.16. For the loopback address, it's 127.0.0.0, 127.0.0.8. And used to communicate with current network is the 0000 dash up to 0.0.0.8. Now talking about assigning IDs for host or network ID, there are rules that we have to follow. In rules for assigning host ID, the host ID are used to identify hosts within a network, and the host ID are assigned based on the following rules. Within any network, the host ID must be unique to that network. The host ID in which all bits are set to 0 cannot be assigned because this host ID is used to represent the network ID of the IP address. And the host ID in which all bits are set to 1 cannot be assigned because this host ID is reserved as broadcast address to send packets to all the hosts present on that particular network. Next are the rules for assigning network ID. Hosts that are located on the same physical network are identified by the network ID, as all hosts on the same physical network is assigned the same network ID. The network ID is assigned based on the following rules. The network ID cannot start with 127 because 127 belongs to class A address and is reserved for internal loopback functions. All bits of network ID set to 1 are reserved for use as an IP broadcast address and therefore cannot be used. All bits of network ID set to 0 are used to denote a specific host on the local network and are not routed and therefore aren't used. To show you the summary of classful addressing is the table below, where you can see the class. Okay, so A, B, C, D, E, and then the leading bits. So the start will be 0. And then for class B, it's the second, class C third, class D fourth, and class E, there's no 0 anymore. For the network ID bits, there are 8 bits, 16, 24, and for the class D and E, it's not defined, not defined, not defined. For number of ID, host ID bits, 24 for class A, 16 for class B, and 8 for class C. So for the number of networks, this is the value 128. So 16,284, 2,097,152. For addresses per network, okay, host address per network. So for one network, for class A, there will be 16 million. Okay, for class B per network, you have 65,000, and for class C per network, you have 256 host address. For start addresses, you can see here, and then the end address. So this is the summary of the classful addressing. However, there are problems with classful addressing. The problem with this classful addressing method is that millions of class A address are wasted. Many of the class B address are wasted, whereas number of addresses available in class C is so small that it cannot cater to the needs of the organizations. And class D addresses are used for multicast routing and are therefore available as a single block only. And class E addresses are reserved. Since there are these problems, Classful networking was replaced by classless interdomain routing or CIDR in 1993. We will be discussing classless addressing on the next video. Thanks for watching. Have a nice day. Bye.